All right, this is section 3.5, part 5. Now we're talking about even and odd functions. Okay, so when you have they give you a function, what you're going to do is you're going to plug in a negative x everywhere you see an x within that function. If it comes out to no change, that function is exactly the same, then what we say is we have an even function. And this is basically what this says. You have this function that they give you, and what you're going to do is you're going to take that function and you're going to plug in a negative x everywhere you see an x with the function they give you. If when you plug in that negative x, it returns to you the same function, then what we say is it's a even function. And so that means that it would be symmetric about the y-axis. Okay, so symmetric about the y-axis. So here's our y-axis right here. So if I cut that in half, it's a mirror image of each other, and that's about the y-axis, okay? Now, when you have a function and you plug in a negative x everywhere you see an x for the original function, and it comes out to basically change all these signs within that function, this is what this is saying right here. After I plug in the negative x into my function, it really just changes all the signs for the function that they gave me. Well, what we say here is it's an odd function. Now, an odd function is going to be symmetric about the origin. Remember, the origin has the order pair 0, 0. Okay. All right, so symmetric about the origin. So what we do is we draw a line, straight line, through the origin. And so what we're doing is we're cutting that picture in half, kind of like we did over here with y. So now that is a mirror image of each other as well, but that's just a reflection about the origin. That would be an odd function. So we're going to try to find out if a function is even, odd, or neither. So if it comes out, we plug in the negative x and nothing changes, we know it's even. If we plug in the negative x and all the signs have changed, it's odd. If neither one of those happen, it's neither even or odd, it's just neither. So let's look at this one right here. So I'm going to take negative x and plug in this negative x everywhere I see an x. Okay, so that's going to be a negative times a negative is positive, times a negative is still negative, so this is negative 2x cubed. Negative times a negative is a positive 4x. Okay, now I'm going to compare these two together. This with this one. And looks like the signs have changed, so I could write this as negative times this entire function. Okay, now look. This right here is f of x. So we could say f of negative x is equal to negative f of x. So basically all your signs changed. This was a positive here, this was a negative here. Well, now it's a negative here, now it's a positive, and that was the only change. So what we say is when that happens, this happened right here, you have a negative in front of that function. That's basically what we're getting here. So what we say is this is an odd function. So we say odd function. Okay, so let's take a look at this one. I'm going to plug in a negative x everywhere I see an x, and then see what happens. Okay, I'm going to bring that negative to the front right here. And then that's going to be negative 3x. Okay, so looks like I can take a negative out of both of those. Negative 1 over x plus 3x. Now again, notice up here we had a positive, then we had a positive. Here we have a negative and a negative, and that's the only thing that changed. Now notice this right here is f of x. That is this right here. So we could write f of negative x is equal to negative f of x, which by definition is an odd function. Okay, so let's look at this one. F of negative x. So we'll have negative 3 negative x squared plus 4. So negative x, this will be negative 3. Negative times negative would be a positive, and then we just have x squared plus 4. Okay, so now let's look. We had a negative here, we have a negative here, positive here, positive here. If you notice, these two are exactly the same. This is the function f of x. So we have f of negative x is equal to f of x, which means if we didn't have any type of change, it's talking about this right here, which is an even function. So here I have an even function. Okay, let's look at this last one. So f of negative x, we're going to have 2 times negative x cubed minus 3 times negative x squared minus 6 times negative x plus 2. Okay, so this is equal to negative times a negative is a positive, times another negative, that's a negative. So negative 2x cubed. Negative times a negative is a positive, so that's still negative because I have this negative right here. Negative 3x squared. And then negative times negative, that's a positive 6x plus 2. Okay, so then let's compare these two. Positive, negative, 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 positive, positive, positive. Okay, so not all the signs changed, but some of them did. So we can't say that it was exactly the same, so we can't say it's even. And since all the signs didn't change to the opposite sign, we had some that were the same, some that were different, we can't say it's odd either. So this one would be neither.